Hi, this is Anna. Anna from SqlDBM. I've got Dan joining me as a guest today, Dan Galavan. Um, this is pretty cool. Thank you so much for sharing in the comments where you guys connecting from. This is helpful. So in my role at SqlDBM, I actually get a chance to work with clients all over the globe. So this is great. This is a good representation, I think, of the industry right now. I'm sitting in California, San Diego. Dan is over in Ireland, and looks like, based on the comments that you guys shared, looks like we have people kind of from everywhere in between, which is good. And this pretty much gives a gives me a start in this sense. What was I going to say? So today we're going to talk about solutions that keep the world going. With the pace of how things are happening, how global we've become, there's a lot going on. The frequency we communicate at, speed at which we create and bring new solutions into the world, and even the tech advancements. Like look at that. That's crazy. And to keep us going, solutions, we need powerful solutions to support the current growth and fuel the future advancements. So those are the solutions we are going to talk about. Actually, Dan will talk about them. Dan, let me introduce you properly so that we kind of get a head start. Dan is a leading data architecture consultant, and just like myself, he works with clients all over the globe. He spent over 2 decades now consulting and advising clients and leading the delivery of data solutions in both private and public sector. So Dan is also a full data modeling lifecycle expert. So there's that. And he's a Snowflake data superhero, which is probably the most curious fact for me. Dan, so what does it mean? How does it feel to be a data superhero?
Hey, Anna. Well, it's pretty normal, to be honest. But that award or recognition comes from contributing to, webinars talking about Snowflake and blogging around Snowflake and things like Stack Overflow and things like that. So it's great to get the recognition in that regard.
Awesome. Well, I've never met a superhero before, so this is historic for me. For me personally, with that, you're going to talk a lot about Snowflake itself. So maybe for context, you could, as an expert, you could tell us what is Snowflake Data Cloud platform and why is it so popular?
Yeah, sure. So the Snowflake Data Cloud is it's, as you said, it's a cloud data platform, and it allows you to securely, do data warehousing, data engineering, analytics, data sharing, and things like that. And there's some really cool things about Snowflake, and part of the reason why it's so popular and it's got such a profile is, for example, you can run different workloads simultaneously on the same data. So in other words, you could run your ETL or ELT workload on the same data at the same time as you're running your machine learning workload on the same data at the same time as you're running your business intelligence workload or whatever other workloads are necessary for your day-to-day. Some other cool stuff, the list is long, but just to give an overview, yeah, some other cool stuff is it's cloud agnostic, so you can get Snowflake on Google Cloud Platform, AWS, Azure, and really scalable. So it's a true big data platform. It scales up, scales out, and stays online all the time while it's doing that, which is, for me, it's still a bit of a novelty. But that as a summary would be what Snowflake is or can help you to do.
Awesome. Thank you for an insightful summary here. To kind of naturally help us segue into what we wanted to talk about, could you explain, start with explaining of what role does a data modeling play in the context of Snowflake data solution delivery?
Absolutely. So I want to start with a quote, actually. there's a researcher in Cambridge University called Martin Kleppmann, and
Okay.
he would describe a data model as something profound, and it not only does it influence how we prepare our solutions, for example, in a data engineering role, how you're going to build your transformations, because the data model is typically the target, but also it influences how we think about the problem overall, because a data model is a communication tool. So probably the best way to really answer your question is, I got a slide. I got a couple of slides actually. So
Okay, bring them
yeah,
on. Bring them on.
yeah. Okay, brilliant. Okay, just bear with me for a moment.
Yeah,
I'm gonna
yeah. And
share my
we're
screen.
structuring this. Yeah, for everyone, we're structuring this as a hands-on lab. So then I'm actually hoping to. Yeah, I was hoping you'd share the screen and walk us through things.
Absolutely. Okay, so the best way to answer your question, Anna, about where does data modeling and where do data models fit in terms of Snowflake data solution delivery, would be to look at data pipelines. Now, what's a data pipeline? Oh, by the way, can you see my screen?
Yes, yes.
You can,
I
thank you.
can see
Okay,
it.
excellent.
Mm-hmm.
So a data pipeline it's really, if you're moving data from A to B, that's a data pipeline. Typically, if you're moving data from A to B or replicating data, there's typically some kind of transformations that will take place, not always, but that's in its essence is a data pipeline, right? And
Mm-hmm.
what you see on the screen now would be an indicative example. And I'm using the word example because they can take different shapes of a data pipeline on Snowflake. Okay, so we have, going from left to right, we have example inputs. A data pipeline does not have to look like this. It can, okay? But you've got, for example, data coming in from cloud storage. Again, just reinforcing the whole cloud agnostic nature of Snowflake. You can hook in directly to Azure Blob Storage. You can hook into AWS S3 buckets, Google Cloud Storage. You can get data from there in what's called batch format. So maybe it's on a nightly basis. You can bring it in micro batches. So every minute or whatever works for you, depending on business requirement. You can use something called Snowpipe, and then that opens up the door as well to things like Kafka. So you're an example of streaming upstream, streaming downstream. So you're talking lots and lots of regular micro batches are faster. So you're getting into near real time territory there. Once you get the data onto the Snowflake platform, and by the way, this is the principle of Snowflake. If you remember when I introduced the topic, you can do all that stuff on Snowflake, data warehousing, data engineering, data science, and all the rest. Well, it facilitates data science.
Mm-hmm.
Sure, facilitates data science workloads. You don't need a load of different tech to run your data pipeline. You can run it all on Snowflake, and that's one of the cool things about it, right? So again, going from left to right, we've got our staging area. So this is typically a copy of data from source. It's replicated there, and it usually looks the same or very similar. It might have additional metadata. Then we will add our transformations, typically, and so on. If you're using something like Kafka, you may be tapping into what are called Snowflake streams, and they go hand in hand with something called tasks, and that tasks help with scheduling and so on. Up here we got our external functions. So this is a relatively new thing with Snowflake, where you can actually call logic from outside of Snowflake. So it opens a whole new door in terms of capability. But at its core, from a data modeling perspective, it's really this piece here around integration layer, around data marts, right? So, and to a lesser extent, you may find yourself doing some data modeling around the staging area. Probably not, because most ETL or ELT tools, ELT is always better these days, extract, load, and then transform, get the data onto your Snowflake platform, then do your transformations there, get the real horsepower from Snowflake. Typically get staging, the tables will resemble how they looked before they came into to the Snowflake data platform or the data cloud. But it's here. This is where the real data modeling happens, the real creativity, the real data standardization, the real view across your data sources. Because with Snowflake or with any data warehousing exercise, the goal is to typically look at data across more than one source.
Mm-hmm.
And typically, right, your sources don't look the same. Okay, they're going to have different structures, table names, column names, whatever it may be, different grain on data, which means, you know, how aggregated your data is or is not. And this right here is manages that. It allows you to get a picture. It supports getting a picture across all of those data sources. So you may model, data model, an integration layer. A classic example is a data vault. You could go with old school relational enterprise data model. And you could argue that a data vault is a type of enterprise data model. And yeah, it is. Data marts. So if you're designing your data marts, data modeling plays a big role here. Okay. Again, just because I got this on the slide does not mean a data pipeline has to look like this, but it just gives you a sense of the different moving parts. Once you prep the data, make it available for consumption by data scientists, BI report developers or analysts or whatever it is. You can start plugging in the likes of any of your, Power BI, Looker. There's plenty of other tools. You can start writing Python directly. And this analysis here doesn't have to happen just here. It can happen early on. So if there's an urgency to get access to your data, for example, for data science purposes, you can point your BI tools directly at staging. But if you want to get a consistency, a good view, a solid view and understanding of your data, you're talking data modeling, you're talking integration layer, you're definitely talking data marts. They're very, very useful. So that's an example of an overview of a Snowflake data pipeline and how data modeling plays a role in that. Does that make sense, Anna? Do you have any questions so far?
This is awesome. That's the real meaning. I guess we usually all talk about, the kind of the end goal of getting the insights from data, but
Sure.
what's happening before is kind of crucial, right? That's the foundation. So
absolutely. And a data model is also, it's a communication tool. So we all know with data models, you can physicalize them in databases and you can put data in them, but they also act as a communication tool when you've got different people in or different roles looking for data or trying to access data and you want to know where it is. A data model can really help with that.
So who are the users? So the end users of of that data model. Are we talking like everyone in the org? Are we talking specific departments? From your experience, who would that be?
So at a high level, it depends on the type of data model. But for this type of data pipeline, right, for the data marts, so let's start with the integration here. Let's say you go with a data vault, right? Straight up, you're talking data engineers. They're going to be in the mix. They're probably going to need support from data analysts to explain from an actual business meaning perspective. Maybe not. Maybe you can separate that, but it's not it's always better that there's a business understanding from a technical perspective. When you get into data marts themselves and the consumers, you're talking business analysts, data analysts. You see a lot more. What's very interesting with the likes of self-service BI, right? You see a lot more accountants getting involved with data. Particularly, like there's a lot. I've seen a number of instances where you have Power BI champions within organizations that are actually very much involved in the accountancy role. So, likewise, if you're talking about scope in your project, a data model is a big help there. So then you're getting, architects, different business data, integration, solution, enterprise architects will all get value from data models. If you're trying to explain at a very high level to the C-levels, a conceptual data model or some very high level model can really help there as well. So the reach of data modeling and data models is vast.
Yeah, that's what we see happening in the industry too. So I definitely have real life examples of customers who are trying to bring as many people on the same page as possible. So
yeah, you hit the nail on the head, and that's the goal of data pipelines as well, is to get people on the same page in terms of reproducibility. And we're getting into DevOps, right? Reproducibility and data ops specifically, reproducibility of results, reproducibility of outputs, reproducibility of reports, getting everyone on the same page. So that's a really good phrase you've used there. it would be remiss of me. I want to talk a bit more about data modeling itself and the considerations, the type of high level framework around data modeling. Are you okay to move on?
Yeah, yeah.
Okay, brilliant. All right. So this is a very, very high level framework around data modeling.
Okay, okay.
Right? So what are the considerations that you need to consider if you're embarking on a data modeling exercise? You don't necessarily need to do all these things, but chances are in some capacity, these will all play a part and input into your data model, okay? That's going to really meet your business requirements, okay? On top of the list is business requirements driven. Just because you can create a big data model that's going to represent your whole organization isn't the same as if you create a small data model that's definitely going to get used by end consumers for BI or data science or whatever it is. That's really going to add value. And if you add value to the business, chances are you have a better chance of getting more business sponsorship to broaden projects in this area. I want to mention briefly as well data modeling lifecycle, right? Especially this is still evolving around the data ops side of things. I'm talking conceptual, logical, physical, right? How do you include that in the data ops space? And it's absolutely possible, but typically with data ops, the focus is on let's get the code written, right? Let's get the data engineering done. Let's get it tested. Let's get it deployed, and you iterate. And that's good practice. But we need to make sure that the data modeling role is a part of that overall iteration or iterations. And it can be done. And it can be done really well. And it's very important to do that, particularly with data pipelines. And that feeds into change management as well. And not just for the pipelines themselves, but the environments, right? How do you get reproducibility with environments? And that includes data models.
Mm-hmm.
Yeah, so repeatability, orchestrated pipelines, okay? So orchestrated pipelines are, you may use a tool. It's like, it's like at an orchestra, the conductor. You know the conductor with the stick, right?
Yes.
And he's making
Yes.
sure that the drum gets beat at the right time and the cymbals get hit at the right time. If you think about that from all the moving parts around data pipelines, that's orchestration, right? Ontologies, definitions. That's like the gold dust of data modeling. Definitions. What does your data mean? And how does that data associate with other data? What are the hierarchies in your data?
Are you talking kind of about documentation, like documenting and your metadata then?
Absolutely.
Mm-hmm.
Absolutely. Because I'm sure we can all think of examples of someone in an organization or project who understands the model really well.
Just one person.
Just one person, right? And let's say they change roles or they whatever, they get a promotion or they change organization or whatever it is. You could lose a lot of tacit knowledge, so the knowledge up here. So if you plan out your ontologies, write them down. That's the way to mitigate that risk. And it's better for everyone. It's better for the project and it's better for the organization. You're talking data dictionaries would play a role in that as well. Just on time. Standards alignment, just mentioning this very quickly. If you've got any, like Europe, GDPR, privacy is massive, right? If you're processing personal data, you need to keep this in mind. But it doesn't have to be around privacy. It could be around healthcare standards like HL7 or FHIR. Could be around financial services regarding, for example, BCBS 239, Basel Committee of Banking Supervision. We don't need to talk about that other than that standard, for example, talks about data lineage, and that plays a role in your data model. So around the metadata in your data model. Privacy and security. We talked about privacy briefly. When you're granting permissions to your data, you grant it on physical structure. With Snowflake, you actually use roles, and that then manages the permissions, but it's inferred. Still all about the data model. Automated testing. Just because it's a data model does not mean that you shouldn't run automated testing as well. So you can do unit testing on data models as well. Methodologies. Kimball, we mentioned Kimball, dimensional data vault, whatever methodology or methodologies you're considering, it's worth looking at. You know, there's well-worn paths here that can really inform you and help with your data pipeline delivery and managing the risk. Okay. Are you ready to move on? Oh, any questions there, Anna? Does that make sense?
Yes, makes total sense. There are some questions people are leaving. By the way, thank you so much for questions. We'll cover them at the end. So then let's go on with the lab, and then we'll kind of circle back to questions.
Absolutely. Okay, here we go. So enough with the theory. Let's see things in action, okay?
The practice, yes.
Yeah, okay. So let's start with a data model, okay? Because if you're looking at a requirements-driven approach, and it should be a requirements-driven approach, then a data model is a great way to capture your requirements. As mentioned, it's not just it is something, of course, we physicalize in databases, or we can. It's also very useful in terms of it's a communication tool. Look, this piece of data is associated with this piece of data. That's where we're putting this piece of data, and so on. Now, in this case, what we're actually looking at is a data vault at a very high level. We're not going to get into data vaults really in this session.
Yeah, because it's a separate topic.
Yeah, oh, absolutely. You could spend a week talking about data vaults. You could spend a week talking about all these topics, to be perfectly honest, but that's but just to give you a sense of what this model represents, the blue, those blue items right there, they're what we call core business concepts, or represent the basis of them is our core business concepts, like person, place, thing, event, other concepts. But you're really trying to identify what are our entities here, okay? And they're blue, they're called hubs. The yellow, that's our attribution, or you're describing our core entities or our core concepts. And, you know, it's like, let's say a core concept is, in this case, it's part. So what this model actually represents is an inventory snapshot, okay? And we look at the part itself, but you know, what are the attributes on that part, and that you use satellites for that. Like, I'm just going to switch to a more granular view, or a more detailed view, so you can see things like the part manufacturer, the brand, the type size, and so on. So that would be a satellite. That would be an example of a satellite. From a purely data modeling, like, basic perspective, it's another table. These are all tables, right?
Mm-hmm.
So let me just go back up to that top level view for a second. And then the green are link tables. So they associate different things within your model. So they associate different core business concepts. So we have a part thing, a supplier thing, a supplier event, inventory event, because an inventory activity took place. And then we have our satellites, which describe the detail around them. Okay, this is our data model. Now, and it's also a Snowflake project. So we're going to actually take this model and we're going to put it into a Snowflake database. Now, there's a couple of things I'd like to draw your attention to here, right? Because we have Snowflake specific configuration that really helps in terms of the data modeling process. So for example, let's take a closer look at the supplier table. And again, this is a satellite, and you can see it's capturing the supplier name, address, phone number, things like that. Okay. Now, yeah. So let's have a look at some of the Snowflake specific properties.
Okay, so you're trying to show the properties. So what are the Snowflake specific ones, and why? I guess why are they important?
Yeah, sure. So there's different configurations we can use here. We have cluster keys. Now, if well, first of all, what's a cluster key? Well, a cluster key, actually, I need to take a step back further because there's a lot to this in a way. So a cluster, when you load your data into Snowflake, and this is another cool thing about it, it automatically manages how it's stored on disk. So it optimizes that. It tracks, it knows where your data is, right? So you don't have to do any kind of indexing or whatnot. But, and it's really good for, okay, I'm going to stick to this because we can get into a lot of detail, right? Yeah.
Okay, high level is good.
Yeah, high level is good. Exactly. So what can happen is over time, if your data changes a lot, your queries can slow down. And what cluster keys allow you to do is force the organization of your data on disk. So you can group your data together on disk in a certain way that you want to do it, right? So in principle, that's very useful. In practice, that's only useful for if you're in terabyte territory, if you've got very, very large tables. Because if you put a cluster key onto a smaller table, well, you will not get bang for buck because two things will happen. One, you won't get the optimization that you expect. And two, another benefit of Snowflake is it automatically updates, keeps your clusters of data up to date in terms of where the data is grouped. And there's a cost to that. So best thing to do with cluster keys is test them out. See if you do actually get a benefit from a performance perspective. And if you do, then put them in. We're going to put one on here for just demonstration purposes. I'm going to group our data based on what would people typically query on. I'm going to go with nation code, right? Just for demonstration purposes. I'm going to save that. And I'm going to do a little bit more Snowflake configuration. So did I actually call that clustering key? I think I did. Yeah, okay. Let me just rename that. Nation code clustering key. And we'll push that through. That's okay. Let's save that. Some other cool stuff in here. We have things like transient data retention and file formats. Now, transient, very, very briefly, is when you have data in tables in Snowflake, it also tracks the history of those tables automatically. Okay, so your DML history. So your changes to your data. Snowflake keeps a history of that, which can be very, very useful. Depending on your Snowflake license, it will track that data for up to 90 days. Or the history, should I say. Because it's subscription based and it's credit billing based, the more history you track, the larger your data, the higher your costs. There may be tables where you don't need to do that. So what transient does is it's a table setting and you're saying, I don't want to track history. And then there's an extra thing that Snowflake gives you, which is called failsafe. And just at a high level, if all else fails, you can contact Snowflake support. You got an extra 7-day window to get your data back. So what we're actually going to do in this case is we're going to set our data. So we check that box, we get our transient, we set our data retention history time. So let's go with 10 days. Okay. So we want to, whatever changes we want to have those on the table. Let me just double check that. That's in there. That's there. We can also do things like configure our table stages. So when you're loading data into Snowflake, you use things called stages. You got internal, specific to a table. You got external that lets you hook up to, like, for example, AWS S3, Azure blob storage, and so on. And they have all these kinds of different settings, right? You can say if we have over a certain amount of errors as we're loading our file, skip the file. So if you're saying over 10 errors, skip the file, right? So on. There's all kinds of settings we can do here, but I'm just going to stick with the data retention and the cluster key for now. I'm going to save that. And there's one other thing. Sorry, Anna, go ahead.
My question is, the changes that you're making, are you making them live? Or kind of what's happening behind the scenes?
Yeah, I've just clicked save here and that's saved into the model. And we're going to actually look at some model versioning in a little while and actually become more apparent, right?
Okay, perfect.
Yeah. So one other thing to draw your attention to, there's a really cool data type in Snowflake called variant, and that allows you to store semi-structured data within your database. Snowflake is very good at managing semi-structured data, and that ties in with the overall principle of all these different things like warehousing, engineering, analytics you can all do on the Snowflake Cloud Data Platform or Snowflake Data Cloud. So that's what the variant data type does. So we've got a variant data type in there as well. Now, I do want to mention very, very brief. Oh, there's lots of things I want to mention actually. Let me mention. So let's say you got lots of people working on the data. So the data model. And you remember you asked who?
Yeah, the users, like
the
who?
users,
Yes.
right?
Mm-hmm.
So let's say you got lots of users, different roles, and a user can have lots of roles, or a role can be distributed across lots of users, or whatever works best for that organization. They all want access to the model. They all want to see the model. They want to navigate it. They want to look at the column definitions, the table definitions, how does the data get associated, and so on, right? Data engineers, what kind of transformations do I need to do? What does the target look like, right? So it's very easy to share the model. So I'm going to share our model with another user. So I'm logged in as a demo, and I've got another user here called data ops. Now, this may be more like a distribution list, but for the demo, I've called the user data ops. You might give that a different name, but I'm going to share this with another user. They can make changes, they can reference the model and so on. And what I'm also going to do is I've just locked it now because I want to make a change here. And I want to add a comment here, right? I want to say, actually, I want to do it on a different table. I want to do it on the supplier table because that's the table we made some changes to, right? So I'm adding a comment here. Hey, at data ops.
Yeah, can you tag them? Perfect, yeah.
Absolutely, yeah. Hey, at data ops, the cluster key is now configured. Can you check that we get bang for buck, right? Because it's going to cost you money. And if you're not getting bang for buck, if you're not getting value from your cluster key, it's not going to work. Now, in a professional environment, you may not word it like that, right? But that's the message, okay?
Yep.
Yeah. So I've just sent a message through, and we can have these conversations on the model and get rid of these comments at a later date, but it really adds to the, especially with larger models, right? You can put a comment on a very specific table and very specific location in your model. So I've the other user logged in. I'm going to switch to another browser, different browser because it's a different login, it's a different session. And just bear with me. On this other login for the data ops user, we have a new model that's just been shared right here. Let me just zoom in a little, actually.
Yeah, it says editing by Dan.
Exactly, editing by Dan Galavan and one user. So let's take, so I'm in a new login. This is the data ops user, and I'm going to check it out. Okay, I can see the model. It's in read-only mode because the other user, which was me, has locked
making changes.
Is making changes, right? So
can you still respond to the comment though?
Let me just zoom in again here. So I'm going to say no problem at Dan Galavan, testing scheduled for tomorrow. Okay. Okay. Now, let's just check our comments. As you can see, that's our latest in the chat. And so it enhances the whole collaboration nature of the model, because like you said, like you inquired about, you can have lots of different users. So I'm going to return to my previous the main screen, and the message is back. Okay, so cluster key configured. But we're going to check, is it worth it? Okay, so that's our comments. So now we're going to go on. I want to mention very briefly data dictionaries. This is very important. We talked about tacit knowledge. Okay, Anna, can you give me what we see here is our data dictionary around tables. So if I look at the part hub table, there's no descriptions in here. This is not unusual, but we can see the color coding draws our attention to it very quickly. So can you give me a description for the part hub? Just give me any text, any will do, and we're going to forward engineer that.
Very important piece of information.
Oh, yes.
So I can pretty much put anything in there, right? And then will that get translated into Snowflake environment?
Yes, exactly. So let me just show you something before we do that, and we're going to do that very soon. We can actually look at the different versions of our model, right? So I've just made some changes there. And if I compare it to before we started this call, okay, I can see that on the part table, there's our comment. All right, and that's going to get put in a database. I can see there's our cluster key and our data retention. Okay. So what we've done there, like in a couple of mouse clicks, I'm able to compare versions, which is very, 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 very convenient. Okay, let's get the data into our database. I'm going to forward engineer. I'm going to generate our SQL. I'm going to copy that, right? Okay, now I'm going to use an interface with Snowflake called SnowSite. And we're going to create a new worksheet. So now we're in Snowflake. And I'm going to paste in our DDL, which is our create script. And
the one
I
you
want to
just
use,
created.
That's right. And I'm going to paste it into, let's go with SIT is our environment. And I'm going to talk briefly about that further in a couple of minutes. So we're on our sit.public schema, and I'm going to select our create script, which includes the comment change we just made, the cluster key configuration, and our data retention setting, and our description. Okay, so while that's running, I want to talk a little bit more about environments. Okay, and by the way, that was the SIT environment, system integration testing environment, right? With DevOps, it's all about reproducibility, and then DataOps is a data pipeline, for example, analytics specific view on that. It's not just your code, it's not just the data, it's your environments, okay? And we're looking at this from a data modeling perspective. So what I've done here is I've actually configured 4 different Snowflake environments, connections in the data modeling tool.
Okay.
Right, got dev, got development, system integration testing, UAT, production, right? And what we can do is we can compare our environments. So I'm running the DDL into SIT. Let's just check, has that completed? That's completed. And I'm going to click on SIT here. It's one of our environments. And I'm going to compare that to an environment I was working on earlier, which is dev. And these are all pointing at Snowflake databases on the Snowflake account that I've just run the DDL on, right? So let me just, oh yeah, upload revision.
You'd want to upload the new version?
Yeah, of course. So we get the latest version.
So you're pretty much syncing them, just making sure whatever is on Snowflake is what you see here.
Yeah, it's a 2-step approach. You're looking for differences, are there differences? And then, like you said, we can sync them. So if you want to align any 2 environments, then this is a way to do it. Okay, so we can see that in our dev environment. Actually, let me switch. Yeah, So we're going from left to right. We're starting with sit, and we're taking a look at dev. We can see very quickly that there's a comment that's not in dev, and we have a comment here, should I say? Very important piece of info. That text is in dev; it's not in sit. And if we take a look at our satellite, we got a cluster key here that's in sit. It's not in dev, and maybe it should be. So we can actually generate our alter scripts to align those environments. Okay. So there's our cluster key. There's our there's our comment and so on. I'm not going to run this now, just from a time perspective. Okay. Let's get back to Snowflake, and let's just check the objects have been created. So we went with sit. Let me just check something here. Public tables. I'm just going to refresh that. There's all our tables. So that's the DDL we generated for, and we've executed that. Now I'm going to just dive straight into it. I'm going to run a data pipeline, right? Now, this is a classic ELT script. Oh, and part of this hands-on lab, we're using Snowflake sample data, by the way. Okay, so each Snowflake account comes with Snowflake sample data. The regions can vary. This sample data is definitely in AWS Ireland and Azure Netherlands, but depending on the accounts, I think Zurich North has a different test data set. The newer one, this is an older one, the newer one has some better test data like JSON, but our ETL pipeline, our data pipeline, which is using ELT, is going to take data from this sample database, and it's going to add it to our data vault, which we forward engineered to our sit database. So starting point, endpoint, source, sync. Okay. So let me run that ETL. Oh, I want to show you something else very, very quickly. Sure, table metadata. Yeah. So we configured our tables. So let me just check them in the right database. I need to switch that to SIT. We're looking at table metadata here, and not just descriptions. We're looking at data across the board. See this difference here? That's the data retention. Yeah, that's the one we configured. And there's a text.
I see my comment. Yes.
There you go. You're influencing the design.
Wonderful.
Yeah.
Oh, that was quick, actually.
Yeah. And then let's just take a look at the, just to verify that our clustering key is in place, our cluster key. And we can see on our supplier table, our clustering key is applied to nation code, and that word linear is a Snowflake internal keyword. That's our metadata. So let's run the data pipeline. Okay. So a quick walkthrough of our data pipeline is we're using, again, our source and sync, our source and target are on the same account, right? So it's an easy pipeline to run. We're doing a classic insert. We're using overwrite, which acts like truncate. We're using all. And what that means is we're actually doing an insert from our source table, which is a supplier table. And we're splitting the data across our supplier hub and our supplier satellite. And same pattern for the other hubs and links, hubs and satellites. And then we populate our link. You can run all these in parallel because of the nature of how the keys are configured, right? I'm not going to get into that now. There's two other things very quickly, Anna, I want to show you. I'm just conscious we want to give time to Q&A.
Yeah, I have a couple questions here that you would want to answer. Yes.
Okay, brilliant. All right. Okay, I'm not going to run the data pipeline, right? Just from a time perspective, but it's there and it's in GitHub as well if you want to try it yourself. But bear in mind, you got to go for a Snowflake account that's got this data set, but just fire up a trial account on AWS Ireland or Azure Netherlands and you're good to go. The other thing I do want to show you very quickly is versioning. We talked about versioning, right? And again, this ties in with DevOps, data ops, and so on.
Yes, version control. So
Yeah.
You were showing the comparison between
Yeah,
before we
exactly.
started the session and what you did during the session.
Exactly. So we can very easily compare our versions to earlier versions within the modeler, right? So again, this is a bit like when we compare the environments there. It's the same principle, but we're comparing versions within the model here, within the modeler. And, we can see that there's our text that wasn't there in an earlier version. There's our cluster key and data retention that wasn't there in an earlier version, and so on. So it's very easy to see what changes have been made. There's a very important thing from a Snowflake perspective, which is data versioning, right? We want to version our data. So if you want to get reproducibility, you want to version your model, you want to version your logic, you want to version your data. So a very, very easy way to do it in Snowflake is we're on version 103 here of our data model. And let's assume I ran the data pipeline. What we could do is actually take a clone of our Snowflake database. So that's going to match exactly our data model plus a populated via data pipeline database, right? That's a very, very straightforward thing to do. It's a very fast thing to do on Snowflake as well, right? So I'm just going to show the DDL here, just from a time perspective. But we can, that's the syntax: create or replace database, clone dev. And we would, you can, so we're on V103 here. So we're going to create a V103 here as well. And if I run, actually, I'm going to run it very, very quickly. And that will clone our sit database. Okay, I've called it dev clone. We can rename it later, but that's it. Now we have a copy that aligns precisely with our data model. So what you've effectively created is a DevOps feature. So that's just an extension of the versioning side of things. So Anna, I mean, I probably, if there's time, shall I summarize very quickly, Anna, or do we need to get straight into the Q&A?
Maybe summarize what we did right now, and then I don't know if you see, there are like 37 questions.
Oh, okay.
We'll pick. You answered. The good thing, you answered a lot of them through this walkthrough.
Okay.
So maybe just summarize what we did just now, and then we can cover the questions that are outstanding.
Yeah, absolutely. So we looked at forward engineering, comparing versions, comparing environments, and how you can align those environments. We looked at versioning of your data in tandem with your data model. And we looked at the logic for a data pipeline. Didn't actually get time to run it, but it's in GitHub. So it's there so it can be run. Thank you.
Perfect. Yeah, I know this is a lot, and trying to go high level is not easy. So totally fine.
Yeah.
I somehow, admin questions that were asked. Yes, we will share the deck. Then we'll share the code.
Yeah, absolutely.
The session is being recorded, so we'll share that as well. So that's good. There's a pretty cool comment from Martin. Data model is the compass and a map to drive through the data forest. Try walking in the forest without a compass and a map. I like that one.
Yeah, fantastic.
Then question, what other methodologies exist for data consumption other than Kimball? Are you aware of any alternative to Kimball?
Ooh, an interesting question, right? Kimball is good because it's intuitive to an end user. It's not unusual to go traditional relational, right? Users can consume relational if the model is user friendly. You can go full wide, so denormalizing without going necessarily Kimball itself, but you still got to keep in mind the grain when you're getting into aggregations, that you don't double count. Another methodology that's worth checking out is Mike 2.0. Mike 2.0. It's a system agnostic, vendor agnostic architectural methodology, and it's got all these kind of subsystems and one of them is around data management and data modeling and warehousing. So that might be worth checking out as well.
Perfect, thank you. Okay, so there are a couple questions you answered. Question, you have primary key constraint. Is this only for informational purposes or not?
Ooh, yeah.
And Snowflake does not enforce primary key constraints. Please clarify.
Yeah, absolutely. Yeah, they're for informational purposes. So that comment is absolutely correct, right? They're for informational purposes. So purely from a data modeling perspective, we could, in theory, forget about them, right? But it's still very useful to configure your, using the term loosely, referential integrity, because it's not, the referential integrity is not enforced. But when it comes to consumers of your model, like BI tools, they can typically read those relationships, the metadata that's so you can configure them. Snowflake has them, just doesn't enforce them. So when you have a BI tool, for example, that plugs into a data model in Snowflake, it can still pick up on the relationships and it can make the data much more more consumable for an end user. But yeah, in terms of enforcing, the only one that gets enforced is actually null or not null. So, oh, and virtual relationships. Sorry, very, very quickly, Anna, I want to mention those, right? What we've got configured here are referential integrity, again, using that term loosely because it doesn't get enforced in Snowflake, and there are pros and cons to that. But let's say you just want to configure a relationship for documentation purposes. We can create things called virtual relationships within the model as well, just to mention that.
Perfect, thank you. And a more kind of high-level question I have from Dave. Hey, Dave. Can you recommend any good books or training resources for staff that's new to data modeling? The best I know of is Designing Quality Databases with IDFX Information Models by Thomas Bruce. 30 years old. What else can you recommend?
Yeah, and that's the thing. A lot of the concepts around data modeling are not new. There's a really good author, Connolly. The name of the book escapes me because it's a long title. That's one that's worth checking out. You see, to do data modeling properly, and we're looking at a relational model. So it's always good to understand relational algebra as well, purely in the context of databases. So any book that covers relational algebra is a help, and it's you don't have to look at too much relational algebra to understand the relational nature of databases and set-based processing. So anything that covers that set-based processing will be very important, like that ties in with SQL. There are books. I'll share some links later. Actually, that's probably the best thing to do.
Okay, yeah, we can save that for later. Question: how do you run the data pipeline in Snowflake? Can it be automated?
Yes, great question. So there are different ways to do it. So you can use Snowflake tasks. So that's how you schedule things within the Snowflake Data Cloud. Oftentimes, though, you're probably going to get more enterprise and use a third-party tool for its scheduling, but you're really looking at orchestration because of all those moving parts in a pipeline. So Apache Airflow is a great tool for that. It uses DAGs, directed acyclic graphs. Check it out because you can't get stuck in infinite loops with them. It's really cool. Azure Data Factory is another one for orchestration, and that's got Snowflake support as well. But if you're just starting off, just start with tasks. Snowflake tasks, they're a good starting point to schedule things.
Perfect. Another question: can we have Oracle tables as source for SnowPipe?
Oh yeah, any source you can hook it in because there's a level of abstraction. You're going to need something that plugs into that Oracle source, whether in an extraction form, but if you're saying SnowPipe, it's probably micro batching or near real time. So you can, yeah, that's definitely that's something you can do. You're probably going to need something extra, as I said, to get something out of the step to get out. Kafka might be an option there.
Perfect. Thank you. Okay, I'm just trying to see the ones we did not answer. There's a lot on CI/CD and data ops.
Okay.
Covered that to an extent. Comparison between models, we did that part. There's a question, if SqlDBM revisions are connected to a version control repository. From SqlDBM's perspective, I can say there is an in-house version control. So then you were showing this, how you can name your versions. You can see different versions, pretty much for unlimited history of changes. So that's what SqlDBM covers from that standpoint for now. There are some things we're planning on in terms of future integrations. So stay tuned for that. Okay, I think that concludes the questions. I know we have 2 minutes only left, so so let's maybe stop there.
Okay.
Perfect. Perfect. Okay. I do. Yeah. There are a couple more that are unanswered, and I'm sorry. Maybe we can share answers later publicly too, if that's an option. I know then you'll share the resources on the books.
Absolutely.
So yeah. This probably concludes this session. Thank you, Dan, so much. This has been great insight for me personally, based on the questions for our audience as well. This is good. For everyone who attended, reach out to myself personally or Dan, maybe on LinkedIn. I'm always happy to chat. I'll actually drop the links to our LinkedIn profiles here just in case. That's pretty much it. Thank you for attending. I want to do more of these webinars. So if there are any topics that are particularly interesting, please suggest them, and I'll do my research. If I'll find a speaker, I'll get Dan to speak again, or whoever that might be. So thank you, Dan, so much.
Thanks for the invitation, Anna. Thank you so much.